So yeah, hi everyone. I'll introduce myself a bit more. Yep, I've been a Datadog for about 4 years now. I've been in the kind of DevOpsy space for a while. Previously worked at HashiCorp and Puppet, and this isn't actually my first rodeo at TestCon or even in Vilnius in Lithuania. So there's me all those years ago, looking very skinny, I'd say, back in the day. But yeah, I've been in this space for a while. I kind of not to get too much into my history, but I've been ops, I've been dev, I've been a little bit of both. I've worked at, open core vendors, but kind of been in this space for a while. So there's a little bit of crossover with what we're kind of talking about. So, you know, what's happened since 2019? So as you can imagine, nothing too stressful, just a pandemic, moving jobs, moving house, and having a baby. So, I've been pretty, I've got quite a lot of free time on my hands right now. But the team from TestCon said, hey, we're spinning things back up, we're opening things up, we're kind of getting talks kind of going out there. So back in 2024, they reached out and said, hey, do you want to submit again? You've spoken at the past, we'd love to do that. So I said, yeah, that'd be great. I hadn't really, unsurprisingly, been pretty busy. I hadn't really got back on the horse. So I was like, okay, this is actually something where some of the tooling we're doing at Datadog and some of the things I've learned around CI visibility and DORA kind of came up. So I sort of went, oh, cool, let's have this talk. So here's a little screenshot of the post they made in LinkedIn back in 2024. And what I found very funny about it was that the biggest response I got from my colleagues and my LinkedIn network was surprised that I was wearing a suit. And yes, that is my suit from my wedding back in 2017, and I don't think I've worn one since. So yes, they're kind of understandable there. But unfortunately, yeah, it was a bit of a letdown. Had to cancel. I had a really bad stomach flu in the end. But out of bad things come good things. And not to stretch the Terminator and AI metaphor too much, but a lot has kind of happened since then, and I thought I'd resubmit back in 2024, but instead of just reheating the original plan I had back then, I've got some new ideas, and lots of things have changed since. Some of the things I'm talking about literally got published in the last month, so I had to kind of quickly add them in at the last minute. And yeah, a lot can change in the space of a year, and it was kind of funny this morning if you saw Lee's keynote. He said, I'm not going to have a Terminator picture in my slides. And I was a bit like, because that's what I did. But yeah, not to get too far ahead of ourselves, let's set the scene and kind of figure out how we got here in the kind of first place. So, in the beginning, software was kind of treated like this, right? We were kind of taking a lot of the ideas that came from the industrialization process and factories and that kind of thing. It wasn't quite one-to-one, and eventually a few different people kind of came around and says, like, how can we apply this to the software kind of world? And a lot of these came around to the original idea of what the SDLC lifecycle was, the software delivery lifecycle. And this gentleman here, Winston W. Royce, he kind of came up with a kind of overall plan that he kind of had. He had wrote an article called got it there, Managing the Development of Large Software Systems. And I love the language that he used. He said like, I'm prejudiced in my experiences, and I want to relate these prejudices to you, which is kind of interesting when you hear it kind of that way. But what's kind of funny about this is he wrote this entire article back in 1970, and he kind of did a little bit of a flex. He said, oh, whilst I was working on, aerospace and rocket engineering in software, I kind of came up with some of these kind of core concepts. And then a lot of those ideas, you've probably seen something like this before. These core ideas that he kind of talked about would end up being what's turned into iterative and agile development later on. So what's kind of funny about this actually, and this kind of ties into some of the ideas of if you give someone a bad idea and say, don't do this, they will ignore the last part and say, go do this. As part of this article, he actually had, hey, this is what will eventually, he didn't say it like this, but he drew a diagram and said, this is a bad way of doing things. You're not doing iterative loops. Don't do this. People ignore that part and said, oh, this looks great. And that's how he ended up with Waterfall. Like he's the unproud parent of Waterfall, I'd say. But essentially, the way you can sum it all up is you want to have small batch sizes and feedback loops. And get used to this slide because I'm going to be replaying this a million times because ultimately everything we talk about is small batch sizes and feedback loops. So many frameworks and many, many years later, lots of things happened. Lee this morning in his keynote kind of talked about it. You had Agile, you had all these iterations kind of came through. And eventually these kind of ideas, these small feedback, small batches and these feedback loops came with the idea of DevOps. Because all of these ideas still concentrated on the early software kind of side of things, the dev side of things, and the ops world was still very like, slow batch sizes. It took a long time for things to get to production. You do yearly releases, sometimes even longer than that. So everything was bunched up, and the larger your batch size is, the worse things kind of happen. So a lot of the DevOps ideas were just taking those original ideas and then pushing them along the kind of idea. All this idea is shifting left, taking everything back to these iteration loops as they kind of go through. And yeah, batch sizes and feedback loops. And in the book Accelerate, they kind of talked about a lot of these kind of core ideas. It was Nicole Forsgren, Jess Humble, and Gene Kim. Remember those names, and if you've read things like the Phoenix Project, you've probably heard a lot of these kind of core concepts. The idea is that reducing the batch sizes and reducing the cycle times reduces the risk and overhead overall, right? A lot of the kind of delivery ideas were like, okay, let's batch everything into one huge release that we do, end of the month. Everyone comes into the office, everyone goes and does this kind of delivery thing, and I've been part of those processes. But ultimately, you're actually making things worse because you go, okay, we're really scared to do these little releases, so let's bundle everything together. But then it's a lot harder to unpick and kind of go through those processes. It's the classic, hey, we're scared of this thing, we'll push it away. That means the thing gets bigger and scarier as you kind of go along. So a lot of these ideas, again, were just batch size and feedback loops. So that's all great. You probably all know about this. I'm not saying anything new, hopefully. But the challenge that kind of came with this was probably the best illustrated in one of those diagrams of that DevOps space with something like CI/CD. So we've got CI/CD. This is the kind of iterative loop. Everything's great, small batch sizes. You plan things out, you code things, you build things. You continuously test, you release, deploy, operate, monitor, and plan back. You're going to all go through there. Everything's great. The key problem here is this little bit in the corner. So it was not really the concept of monitoring operating. We've actually got pretty mature in that space. Hey, I work for an observability vendor where we do a lot of this kind of stuff. But you had the kind of key problem. Quis custodiet ipsis custodes, for people who don't speak Latin or people who have seen the Zack Snyder movie or the actually much better, in my opinion, Alan Moore comic original, roughly translates to who watches the Watchmen. So the kind of key idea here is like, hey, we're monitoring this stuff in production, but what about that CI/CD pipeline? Like, how does that stuff get to there in the first place? So we just came after lunch, so I don't want to get everyone like putting their arms up and getting kind of involved, kind of customer, audience participation wise. But a little kind of question for the audience here. Just think of it in your head. In your kind of organization, who owns CI/CD? Not just who runs it. If something goes wrong, who's in charge of fixing it? And that's the entire thing, right? It's not just, hey, it's the deployment to production. It's your tests. It's all the various different pipelines you've got. And honestly, the question or the answer you'll hear the most often is no one/everyone. Because essentially the idea is that they are the same thing. If you're relying on everyone to be a good citizen and kind of go through, that doesn't really scale very well, right? Because if I'm trying to deliver this one bit of code and this other test fails over here, why am I spending my time trying to go fix that thing over there? Ultimately, you have the tragedy of the commons. If everyone's in charge of something, then no one's in charge. You need to put someone in charge of it and have that kind of incentive there. And yeah, if everyone knows it, no one does. And it's what we'd call, if you've heard the kind of term in the coding world, smells, right? It's a bad thing. It's a governance smell. You're relying and kind of pushing and lifting up the carpet and sweeping all the stuff and going, yeah, let's pipeline, CI/CD, let's just throw it under there. It'll kind of fix itself. And yeah, ultimately, you need to rejig how you think of SDLC, the software delivery kind of lifecycle here. You need to think about it like a product. It's a product where your own internal engineers and, not just engineers, but your entire process, product teams, testing teams, deployment teams, they are your end customer and you are in charge of them. Cool, okay. So if those people are our customers, what feedback are we getting from them? So you've probably heard all these, probably in your kind of teams, our pipelines are too slow, it takes us ages to get anything kind of done. Test the flaky, run it again, we're in that space. Hey, you're getting a little bit of a Schrodinger's cat situation. The test failed. We're not sure if it's because an actual test failed or the setup we have isn't doing things in the right way. And the key thing, especially let's say I'm putting on my business owner hat, ultimately the bit I care about is like, hey, we can't release to production, we can't get features to our customers and deliver value because of our deployment process. Ultimately, that's the key driver behind everything, right? Like everyone moans about tests being slow, everyone moans about flaky tests and all that kind of thing. But ultimately, the key driver here and the way you get your people holding the purse strings in your business owner's attention is we can't deploy to production because of these problems. So that's all bad, but how did we actually get here in the first place? So first things first, pipelines left the data center. Back in the day, things were a lot simpler. You probably just had one machine, maybe some Jenkins instance or cruise control, maybe if you're a little bit older back in the day. But as complexity increases, your CI/CD pipelines increase, and everything's increasing complexity. You're moving to serverless, you're in doing agile stuff, you're doing DevOps stuff, and because of that, the complexity of your pipelines increases as well. And yeah, ultimately, testing scaled faster in observability. The idea of like, hey, here are our tests, here's our kind of processes there. Testing, as I'm sure this audience here, we're at TestCon, it's always kind of been that kind of more, hey, that's the uncool bit. The bit we want to see is like, oh, here's all these graphs, here's everything that's kind of going on, here's our site, it's all running live, here's all our kind of metrics. It kind of scaled a lot faster than that. And ultimately, teams prioritized your production telemetry over CI/CD telemetry, which again makes a lot of sense. From a business owner, again, putting on my cynical business owner hat, who cares if the CI/CD pipeline is slow or has problems if the end user, the customer, is getting their value and everything's happy? It's a bit of a short-sighted way of looking at things, but that's a pretty common opinion. And the idea is that every technological trend we've had has put greater strain on the CI/CD systems you've got, both the people and the process and everything that's kind of going from there. And yeah, there's been a lot of change in the last 10 to 15 years, especially in the tech space. And I know that some people here probably want to avoid it. Ultimately, Gen AI is all part of this trend as well. Hey, I am someone that loves Claude Code. I was doing some stuff earlier on to it today to help out a customer, but it's not a free lunch. And I mentioned, things are changing really, really fast. So DORA, we'll get more into who DORA is and what they kind of do later on, have released 2 reports about the impact of Gen AI on the SDLC process. The 2025 one was released literally 2 weeks ago, so I had to kind of scramble and add some extra stuff in. But ultimately, it's, if you're working with teams and you're using AI, I'm sure some of the stuff we're going to talk about is a little bit of a, obvious kind of scenario. A lot of people are kind of experiencing this, right? But it's good to hear it with tangible metrics and values, because as you'll kind of see in this talk, it's very easy to say, oh, Gen AI has been bad for our team, because again, everyone complains about stuff. But if you have solid stats, like we're going to see in the instance, you can actually give that tangible value to say, like, okay, here's the value we're getting, and here's the challenges we're kind of having with that. So they kind of summarized it with this concept of Gen AI and the productivity paradox. So it goes a little bit like this. Here's the first part of the graph. It's a mixture of kind of surveys and internal discussions they've had in tech. But the first kind of graph they used is like, hey, Gen AI is really, really big. Again, a pretty obvious kind of statement here. In this survey, 90% of people are using it in their stacks. Honestly, it's probably even higher than that, because how do you define AI these days? And half the products you're using are probably using AI behind the scenes, either telling you they are or going from there. And the idea is that, as that adoption rises, you start to have a few problems that kind of come through. And the key illustration here, I don't know if you can, it might be a little bit small for the people at the back, is that we have this kind of graph of the kind of things that come through. The main thing that keeps coming up and up in all these kind of surveys and graphs that we kind of see, individual performance increases, or at least perception of individual performance increases. But at the same time, you can see that one over there, the software delivery instability, that has gone up as well. And there's a little note to say, by the way, this is a bad thing. It's not instability has decreased onward forward. It's individual people are going, yeah, this is great. I'm using all this Claude code. I'm doing a bunch of stuff. I'm doing languages I've never touched before. But as part of that, your stability has gone down, which makes sense. You're kind of, turbo powering all these people that, I've never written TypeScript in production before, but there have been times when I've gone like, cool, Claude, fix this thing for me. Oh, that's gone great. And I just throw it at a bunch of people and say, yeah, this is all pretty good. And it's like, no, you didn't follow any of the stuff. Where's the test? Where's everything kind of going through? So ultimately, there are trade-offs there. Whilst the Gen AI is boosting those individual experiences, they're getting the faster workloads, the higher satisfaction, better sense of code quality. At the overall level, the idea is that these DORA reports are saying delivery throughput and stability actually declines. So the progress for one individual developer, all great, but there's a lot of misalignment everywhere else, and we're not even getting into the ethics and security of things as well. We're trying to concentrate on the scope of what we're trying to go for there. So those trade-offs really matter. And yeah, just highlighting the kind of it there. And yeah, like the other survey from 2024 was saying that basically as the delivery throughput kind of goes through, for every 25% of AI adoption going up, delivery throughput goes down by 1.5%, and delivery stability goes down by 7.2%. So that's bad overall for a team, even if the individual people are having more fun with these kind of tools. And I'm going to hammer this home and home again. The key highlight from the 2024 report is the field has forgotten one of DORA's basic principles, the importance of small batch sizes. And the thing is, Gen AI is a little bit of, it's giving you that thing. And a lot of these tools, when you tell it to go, hey, go fix this code for me, at the end, because they want you to use it more, it will say like, oh, I noticed this other thing. Why don't we do this other thing as well? And I've been there. You can kind of get a little bit drunk, Gen AI drunk, and you'll say, oh, I'll do this other thing, I'll do this other thing. And eventually you've got 50 commits in a PR, and you've gone like, okay, I was only supposed to be fixing the small thing. So you can definitely get into that areas where you want to make sure, hey, what are we doing this all for? It's to deliver value, it's to have small batch sizes, it's to be able to have these kind of feedback loops. And yeah, the key idea is no such thing as a free lunch. Whenever there's an improvement to one area, there's going to be a counteract, downward trend somewhere else. Cool. So talked about the bad parts. We talked about the bits that are having problems. How do we fix this all? So again, yeah, it's everyone's problem. Hey, yeah, as we go through, we'll just tell everyone, hey, buck your ideas up, do some more tests, fix kind of things. Ultimately, that doesn't really work at scale. And we'll go a bit more into it later on when we go through some of the case studies. But Slack, the I imagine pretty ubiquitous, messaging tool. We use it within Datadog. The key thing they highlighted when they kind of went through this kind of process was it's impossible to keep flakiness from entering the system by relying on people to do the right thing. In the early days, when they're a small team, there was a collective consciousness, everyone kind of went through. When there's a small team, maybe 10 or so people, everyone's kind of just doing a little bit of improvement as they go through. But ultimately, hey, I've got a PR to fix. We'll go through some of the numbers later on, but you've got like sometimes hundreds of builds going for a day. If someone else tests fail, I don't want to be sitting down trying to fix that stuff. Ultimately, I'm trying to deliver my thing that my boss wants me to go through. So relying on everyone to do the right thing doesn't really work at large teams. You need to fix things holistically at the top-down scale. And yep, shifting left, I'm sure everyone's kind of heard the term here. The idea is we're taking a lot of the core concepts that came with, delivering things and DevOps and kind of pulling that in to your actual software delivery lifecycle itself. So it's not just about like, hey, we're delivering things, we're releasing them, we're monitoring them, we're coming back. The actual pipelines themselves, a bit meta, kind of looking down on how everything's kind of going and saying, how slow are we kind of building? How do we fix things holistically? If our tests are flaky, who's in charge of actually going and fixing them, and how do we do that kind of process? So if we're going to fix things holistically, we need data. We can't just, flap around and kind of figure out how things are going on. So if we talk about some of those, common quotes and references from the teams as well, we've got like, hey, tests are flaky, Titans are slow, we can't go through production. We need to get tangible, actual numbers between those ideas. So it's not just slow, how slow, not just flaky, how flaky, where and which ones, how long it's been happening, why is this happening, where do we need to actually focus this effort? Because if you go like, let's just try and fix everything at once, you're going to be basically jacked where you were. You're again relying on that collective consciousness. And there's a few ways to get this kind of information. The quote unquote easier way, or at least the kind of more human scalable way, is qualitative kind of measures. So surveys. Good part of this, pretty easy to set up. Just send out a Google form, send out some sort of NPS kind of score, and you can get kind of good numbers. It gives you a good, leading indicator, smell, smoke, trying to figure out where the kind of key problems are. And it might be as simple as just going to your teams and going like, right now, gut feel, where do we need to kind of fix this? But the problem with that is people are people, susceptible to bias, and it's hard to measure over time. The way that people respond to surveys, even if you give them like a tangible 1 to 5 number, 5 being the best, 1 being the worst, people are like, 3, 4, and then a month later you fix everything, they're like, oh no, I'm still pretty depressed, maybe still a 4. Like, you don't actually have that kind of tangible, we turned it from this number down low kind of thing. So, generally, the key idea with the qualitative kind of side of things is use the surveys to kind of get those focus areas and measure the broad overview of things and get that kind of satisfaction number. And ultimately, we're doing this for the people. We want to make sure they're happy and kind of healthy and going through, but those numbers are a lot less tangible than how slow is the actual kind of pipeline going through. So, something like, hey, how do you feel about things currently? Just like straight up gut check, like, hey, 1 to 5, how do you feel about our current processes? Feedback sessions, guilds, ride-alongs, embedded DevX kind of team members. There's a few different ways of doing things, but ultimately you need to get that kind of vibe, essentially, get the vibes of the team and figure out where the kind of problems are. Cool. So the flip side of that is the quantitative measures, so systems data. Like, hey, I work for an observability company. This is literally our bread and butter every kind of day. So the idea is you flip the pros and cons. You're alleviating the bias. It's much easier to measure things over time. You can expose the bottlenecks that people might not even, maybe they're not conceptualizing it, or maybe they've been hidden away. Having those tangible numbers is a lot more useful. But the con side of it is, hey, it's a lot more complex to set up. You're probably going to have to figure out your tooling. Depending on what your tooling is, you might not even be able to pull those things in natively. But the key ideas here are like, hey, okay, we've taken that gut check from this other team. We've got these tiger teams and said like, okay, turns out the front end guys are the ones having the most problems. Okay, let's go into the front end teams. Let's figure out what metrics they're using. Let's see how long the builds are taking. And then you're kind of having that dedicated technical ownership of these problems. Instead of just everyone going, everything's slow, we can't figure things out. We need tangible, actual points that we want to improve over time. And then we can remeasure how people are feeling afterwards. And there's a few different ways people have kind of handled this. I've even seen a few other talks today talking about the kind of DevX teams, like having a dedicated DevX kind of experience. For the more corporate teams, they often say something like an enterprise software factory, ESF. And a lot of people like the CCOE, Center of Excellence, so Cloud Center of Excellence, SDLC Center of Excellence, CI/CD Center of Excellence. Eventually, the acronym gets quite long, and I think it gets a little bit less useful. But ultimately, the idea is like, hey, again, ownership. You need a team that actually tangibly cares about this and has measures that actually kind of go out and want to fix this. Cool. So what are some of those numbers we can look at? So something like, what's the 95th percentile and queue time of the builds you have right now? And that gives you that kind of developer feedback speed. Classic one, how often are your pipelines successful? You know, if it's literally 50-50 right now, it's a coin flip on things going through. That's definitely something you want to go fix. And how long does it take for someone's code they're running on their machine to actually get deployed to production? Ultimately, that's what we're trying to do, right? Code on a laptop isn't providing any value for someone unless, you're delivering the binary to someone. But the idea is if it's not in front of customers, it's not making any money. So code on a laptop is useless in terms of like the actual business's use case. So if it's taking you a month for someone like, hey, I fixed this ages ago, but I'm not getting it into our endpoint, our production point for a month, then hey, that's a month worth of value that you're kind of losing there. So ultimately, that's the key thing that business owners really care about. And yeah, there's no silver bullet for all these things. There's a lot of factors can lead to slow and blocking pipelines. It could be infrastructure related. It could be architecture related. Maybe you're using a framework that people don't know about, maybe using older code, but ultimately there are kind of like leading indicators and smells you can kind of go after and figure things out. It's up to you to use these kind of tools and surveys to go, okay, we can't fix everything at once. Some of the stuff we're locked into, maybe we have to, for example, build in Windows, kind of go from there. We need to have these ideas of these are the bits we want to go after first. And the idea is that even having these tangible metrics compare over time is already a win. Before you've even made the improvements, you've gone from, hey, things are bad, we don't know where we're kind of going, to things are bad, this is how bad. Cool, okay, now we can figure out locating budget and team and resources to these individual parts. If everything goes through and you look at all these stats and it turns out everyone's just a bit moany and you've got 90% success rate and actually you can get code from your laptop to production in 5 minutes, then hey, you're probably in a pretty good place. Nothing really to worry about. But most of the time, you're probably not in that place. And that's the kind of key idea, right? We go from a very intangible vibe of our pipelines are too slow to, hey, we've taken these surveys, we've gone through, we've kind of figured these individual teams out, to staging to prod deployment has increased by 20 minutes in the last 6 months because of extra acceptance flows we added because we were having issues with post deployments. Cool, that's something we can actually go and tangibly fix. You're going from that like, hey, things are slow to, hey, it's slow because of these new acceptance flows and it's gone up, in the last by 20 minutes. Okay, how do we fix that? Can we parallelize these tests? Can we refactor them in general? Can we just throw more compute at the problem? Right now, we've only got a single core running all these CI/CD pipelines. When we crank it up to 8 cores, and then have those kind of conversations and numbers and go like, okay, we've gone from again very intangible, things are slow, everyone's moaning, to here's a tangible thing. I can take this to a business owner and write, like an executive summary and say, here are the problems, here's the problems we can go through, here are some of the solutions we can have. It'll cost us this much, we'll require 3 people for 3 months. You can actually have like an actual number you can give to someone. And the idea is, yeah, you're turning those vibes into actionable insights. So, it's all very up in the air, it's all very top down. How does this look like in real companies? Let's talk about some case studies. So flaky tests, we kind of talked about them earlier on. They're a great target area because they are unequivocally a bad thing. A failing test isn't that bad, right? Ultimately, a failing test could be a good thing. You are highlighting a bug or an issue that you didn't have before. But flaky tests are both the worst world. The worst of both worlds, you're time wasting and you're reducing confidence in general. So the idea is like, hey, in a world where you've got a failing test, cool, I go fix the code, or maybe the test ran in a bad way. A flaky test is, okay, we've not only run it again, okay, it's passed now. What does that mean? Is our code buggy, or is it because our tests are kind of failing? So it's one of the key areas to kind of go after. And there's a few different ways to kind of go over it. Simplest one, auto retry. That's like a very kind of pushing the problem away against kind of sweeping it under. But, you know, if you're solving the flaky test in general, maybe that's the first approach. You can also do quarantining. Hey, this test's a bit flaky. We don't have the time and resource to go after it. Quarantine it so it doesn't run on certain kind of runs. The real fix is obviously isolating it, refactoring it. Oh, it's because it's dependent on time. It's dependent on this kind of framework. We kind of figure it out. But there's a few different ways to kind of go through it. And Slack, they actually went through this, right? They had 120 developers. They're doing 550 pull requests a week. There's 16,000 automated tests on their Android build and 11,000 automated tests. Probably more now. This is in 2020 to 2021. But the idea is every time someone's pushing a commit, because they have to support Mac and Windows and Android, and you know this is primarily in their front end team, they have to support all these builds. And every time someone was pushing a change, something else flakily would change, and then you're like, okay, well, okay, do I have to go fix this? I'm on the iPhone team. Why am I being like flagged for these Android fixes? Am I actually causing a problem, or is that something completely unrelated to me? And they kind of went through the same kind of process. It's a little bit blurry there, but they basically they kind of stood back and said, okay, here's the problem we have. Let's build this workflow where we say, like, if test pass, great. If test fails, okay, figure out, has it failed before? Is it a flaky test? Okay, automatically isolate it, open a JIRA ticket to that team and say, you have to go fix this. So ultimately, the real fix was going and fixing the tests. But you go from things are flaky and we don't know who to actually assign it to like we're actually having a tangible workflow to kind of go do that. And yeah, this is actually some of the code they wrote for it. So essentially they're going through writing some if-else logic. And then on the right, you can see, ironically, a Slack message that goes through and says, hey, you have a flaky test. I've assigned you a JIRA ticket. Go and actually fix it. So you've gone from that, you know, tragedy of the commons, all the things are failing, no one's kind of going through, to you have been assigned a JIRA ticket. That again, that's tangible metrics. You can put that into your JIRA boards, you know, doing agile flows. You can figure out this team needs more resources because they're having to go through and do all these kind of JIRA fixes. And it was a resounding success. They went through from a 20% success rate, which is pretty bad when you think about it, to a 98% success rate only a few months later. And it basically made things a lot more stable. They figured out where the key problems were. That was one of the good things about it. It wasn't just we're isolating these tests and kind of pushing the problem away. It meant because they were going and investigating these problems, they could actually get tangible results and say, oh, it's mostly a third-party API problem. Cool. We should mock those better, or we should handle those in a different kind of way. So it really gave them that real kind of feedback. And what I really loved about it was that they did the surveys. A lot of these kind of case studies that I was looking at, they didn't do the surveys afterwards. They went through and said, hey, how has this improved your life tangibly as one of the developers and one of the testers? And you know, you can see from the survey of the people that came through, about 60% strongly agreed that everything was a lot better. So that's a real kind of tangible thing. And that's the kind of key idea, right? You want to celebrate these successes and you want to be able to kind of go through. And another example is us, like Datadog ourselves. The key thing is, and not to stretch the dog metaphor too much because we use it quite a lot, is we do eat our own dog food. So the core platform itself for Datadog, and these numbers are probably a bit out of date because it's from last year, the main platform for the main code for the platform itself, monorepo, we're about 400 different devs working on the same thing. There's a lot of cross-team challenges because of that. You know, we're dealing with 1,000 integrations, you know, multiple different cloud vendors, all these different kind of cooling from there. So what the team started doing is going, we're an observability platform. We can build these dashboards. We can consume these metrics and say, here are our tests. Here's how many are failing. We can actually assign the kind of tooling to there as well. And one of the key things about Datadog is because we can dog food these problems, we know that real people are having them as well. We use Datadog to monitor Datadog, and then our customers are using Datadog to monitor their tools. That means we know they're probably in the same boat, and we can take these things that we're using internally and then deploy them as real features that we can use for customers as well. So one of the kind of tooling is part of that. Test impact analysis, which probably a few people in here have heard of it. The idea is instead of running your entire test suite every single time, you just do selective tests based on the code that's changed. You know, it's not, again, not a silver bullet. Maybe you do want to run your entire test suite, but the idea is you can get a lot faster feedback for those kind of processes. We can take a lot of the tooling that we've pulled in, build out of the box dashboards. So instead of having to custom build, hey, I've got GitLab CI kind of things going through, we can do that automatically. And the key thing is we have a lot of machine learning and AI stuff behind the scenes that can automatically look at a failure and say, this is a quote unquote real failure, i.e. code that's been changed, or this failed because we didn't assign enough RAM in our GitHub Actions or in our GitLab CI or something like that. And yeah, again, really successful. We had about, went through the test impact analysis. We enabled all feature branches. We were saving about 6,500 hours of CI time a month, about 19 hours saved per dev. And it saved us a bunch of money as part of this, right? Because ultimately, if we're running less entire suites every single time, we're actually getting a lot of cost savings for this, and that can be distributed to other kind of teams as well. And then we had the ability to have, and we have this for customers now as well, a CI health dashboard overall. So right now, what is our, finger in the air temperature of things? How are things improving? What's the median kind of speed that we've kind of gone through? How are things improving? If someone comes to us and says, how long does it take to get to production? We got that kind of tangible number. And yeah, we can kind of go through, and we can even have these kind of inbuilt dashboards that say, what was the core failure that kind of we went through? Was it a test failure? Was it a build failure? Was it a dependency problem? We can kind of go through that as well. And again, the idea is that you want to get the human feedback and celebrate wins. A lot of the time, these kind of processes where we're going through, as Lee put it, having these glue coders, and as a lot of people in here know, QA and QE end up being the dog's bodies. They have to do all of this stuff. You want to, you not want to celebrate this thing. It's not a death march. It's not, a bad thing. Oh, you've got the janitorial duty. You have to go fix this stuff. It's improving people's daily work lives and making things better and getting production value. So have awards and praise, have lunch and learns. Treat these improvements in the same way you treat a new feature that gets kind of deployed. So that's all great, but we're still kind of, laser focused on CI and CD. We want to have a better kind of holistic view of everything, right? CI/CD is a big part of SDLC, but it's not the be-all and end-all. How do we measure everything in the aggregate overall? And that's where we come back to DORA that we had earlier on. So not this DORA, confusingly. There is another acronym for DORA that I think some other people have talked about, which is the Digital Operational Resilience Act. This DORA, which is the DevOps Research and Assessment Team, originally was founded by Nicole Fosgren, Jess Humble, and Gene Kim, which, if you cast your mind back, wrote the Accelerate book back in the day. They formed it back in 2015, eventually got purchased by Google in 2018. But the idea is that these core concepts are not tied to a particular cloud or anything like that. They are generalized ideas that you've got. And I actually really like their new logo, little animated. Oh, great. And that's quite new. I think that's only from last year. So DORA is a large kind of thing. We don't have time to kind of go through everything here, but we're going to concentrate on this middle bit, this software delivery. There's 4 key metrics that we've got. So what are the DORA metrics? You've got deployment frequency, you've got change lead time, you've got change failure rate, you've got time to restore. The idea is that these are tangible metrics you can look at. You can go through and say like, hey, are you an elite? They call it like an elite team. If you are someone that can on-demand deploy multiple times a day, only takes you an hour to get lead times kind of gone through. You've got, your failure rate might be 15 to 0%, and your mean time to recovery, MTTR, is about an hour. You're in that elite space, and that's a kind of key North Star that you can kind of aim at when it comes to these overall things. So, and the idea is that these ultimately are the kind of key metrics of a good SDLC world. They are not just CI and CD kind of parts to it. They are significant, but there are other parts to it, performance testing, delivery kind of functions. But the key thing is these core metrics are generic and can be used by any sort of individual team, regardless of the technology used behind the scenes. And how do you really start that? Same with what we talked about before. You set those baselines, you start the conversations, you map out those flows. You need to have buy-in commitment from everyone. And ultimately, when you've got all that going, you just do the work. It's just like anything else. It's just focused on making sure that kind of neglected part of things, the CI/CD, the SDLC, your QA and QE are kind of owned and partnered as part of that individual process. And of course, take the feedback, loop it, and repeat it. It's the same as we had everywhere else. Batch sizes and feedback loops. And the idea is that these are system outcomes, not individual KPIs. You don't want to get into that world where you're kind of looking through these DORA metrics and saying, hey, why aren't you contributing more code? Why aren't you doing more PRs? You're measuring things holistically. If you turn it into that kind of competition, you get back into like everyone just cooking the books and using the metrics as well. It's an overall, idea. It's not a quota. You want to have that culture over dashboards, which is funny, obviously coming from a dashboard company, but ultimately they are part of the original process, but culture is the main thing you need to really change. Cool. So what have we learned? CI and CD is a product. Give it an owner SLOs. Measure what matters in your SDLC process. Use DORA as a baseline for having that SDLC standard because it's generic across whatever kind of tooling and systems you're using. Have those smaller batch sizes, get that faster feedback, and get that safer and faster delivery. And have the batch size, small batch sizes, and have those feedback loops. The idea is you want to take those batch size and feedback loops everywhere you've got. Make the work visible, celebrate it, have those teams, don't turn it into a death march, don't turn it into a boring work that everyone has to do, make it tangible and reward the people and talk about it just like you would talk about feature releases. And I got my 5-minute warning, so perfect timing. On to the Q&A.
Thank you, Peter. We have one question in Slido. Guys, if you have any other question, you can drop them in Slido or maybe raise your hand and I will support you by asking them. Does Datadog has an AI offering app or agent for real-time logs analysis? In example, new errors, AI insights, etc.
We do indeed. The key thing is, we've always had ML behind the scenes, and when you think about it, LLM is just an extra L on machine learning. So we have the ability to automatically go through, the individual, logs, traces, metrics. We have a new feature called Bits AI. And what that can do is it can do an agentic flow where when something goes wrong, it goes, okay, based on this, I'm going to look at this log. Oh, this log has this error in this other kind of part. And it can do all the kind of flows we have in there as well. And the key thing with Datadog is, we are both consumer and producer. We can consume the core metrics coming in from your AI tools, but we can also use our AI tools to kind of solve those kind of problems. But yeah, come talk to me afterwards. Happy to kind of talk about that. We are at a conference where lots of people talk about AI. I mentioned it in those kind of ideas. I don't want people to think I'm a little bit of an AI skeptic, but I use it. I use these kind of cool things. There's some good stuff out there, but yeah, you still need to have that observability and buy-in and value and guardrails that even Lee in this keynote kind of talked about as well.
Thank you, Peter. Big applause to Peter.